everyone. Oh, my voice is audible. So I will start with what we have discussed. So in last class, we have started discussing about the cloud computing. Okay. So when we are actually taking this idea into our mind, we can actually consider a scenario where we actually need these computing resources for some kind of a application, such as an instance where you are building your own company. So let's say you're building your own company and you want to develop your services over an infrastructure which is available in the cloud. So you need to offer your services to your customers through a cloud service. So your customers will be able to access the cloud and obtain services. So if you are a startup company and you want to develop your own services, you will be able to you have to focus on building your own infrastructure. So in the last class, we discussed about something related to how we can use cloud computing, for example, in cloud computing as an example. We discussed about the infrastructure as a service, where the infrastructure is provided for the user to build their own infrastructure and have flexibility in designing the components of the infrastructure on their own. So in such kind of services, using such kind of services, a startup company or an individual person can use the infrastructure to build their company and then provide the services to their customers. So this is where these computing technologies come into play in the real world. Also, I mean, we discussed about other types of services that comes with cloud computing. So we focus mainly about cloud computing in the last session, where we discussed about the cloud computing. So the cloud computing is the computing done at the cloud servers, which are located in a certain location. So based on the data center where these servers are located, the cloud computing will be done at that place. So there's an actual location for this computing to happen. So based on that actual location, the computing methods are different. So there are mainly three types of computing methods that are proposed for networking scenarios and for like IoT applications. So the other two type of computing methods are like fog computing, edge computing. So in last session, we started discussing about cloud computing. So we will discuss about that first. Then we will discuss about the fog computing and then the edge computing. One student has a question about the project. So whether you can use any other MQTT broker for the project, like Adafruit.io, totally fine. You can use your own MQTT broker for the project. It's totally fine. You can use it. So I mean, you in the project you can use your own you know systems, or I mean you can use different softwares to develop the MQTT server part, and also you can use a different IDE for coding and those kind of things. And also mobile application side, you can select the different mobile application than what I proposed. So you can customize those things as per your requirement or as per your preference. If you are using those kind of softwares, you can give some reference onto uh, onto how you obtain those resources. So maybe you can mention those reference details in your report. At the end of the report, as references, you can mention like from where you got this the software. So there's actually a certain website or certain article or some kind of a domain that provides this service. So you can include the references to those online services in the standard format. You can use IEEE reference format or something, and use the standard referencing format and include the resources that you have used, which are kind of new resources that you are using, and then you explain. You can just reference them in your report. So that would be sufficient. So you can use any softwares that are related to this function from, related to the functions related to the MQTT communication and the communication from the end user to the broker. You can use some similar softwares and some suitable softwares according to your preference. It's totally fine. You mention how you got them and from where you got them in the report clearly. And then in the last class, we have started discussing on this topic related to the different services that the cloud computers, cloud service providers provide. So one service is the infrastructure as a service, which we call as IaaS. And second one is the platform as a service, which we call as PAAS, and software as a service, which we call as SAAS. So with these technologies, with these service models, the amount of control that you give to the user varies. So what I mean by that is that if you are given the infrastructure as a service, then you can control a lot of components in the cloud service. You are able to control the application data, which are related to the software building of the service that you are giving. So, and then you can control the operating system that you are using to do your operations, like building softwares and other, installing softwares and related work. Then you can also have control over the middleware softwares, which are able to give you the interface between applications and the operating system. Between the applications and the other services that are other cloud servers that are there in the data center. So whenever we will work with the infrastructure as a service, the customer in here who are using this service can develop their infrastructure according to their own expectations. So for example, if you're starting like a company, as I discussed before, you might need to build your own softwares as you want. So for that application and data management, they can be done using this service, infrastructure as a service. Also, you can have control over the operating system, which you can select as you want. Like you can select either a Linux operating system, Windows operating system, and so on. Then middleware softwares also, you can decide on your own what kind of interface softwares you are going to use to access different services that are available from other cloud servers and other devices in the network, in the internet. With all that, if you're having a company and you want to give services to some specific customers of yours, you can build your own softwares, you can control, you can have these operating systems under your control and the middleware software under your control. So the cloud provider will be doing the provisioning of services related to networking, um, hardware provisioning, storage, resource provisioning, and virtualization softwares. So what we mean by networking in here is that the cloud service will provide you the network resources that you need to connect your your cloud service to with the other components, other network devices, other components in the network. So you will be provided with the routers, switches, and other internet connectivity, LAN connectivity, in order to connect your device into other devices in the network. So the networking resources will also be provided in this instance. And those networking resources mean that they will be providing you with the necessary components to connect your cloud server with other servers and other network devices in the network. So you will be provided with routers, switches. You will be provided with internet connectivity and LAN connectivity. So with all these, the cloud service will ensure that you are connected to other servers and other devices in the network, so that you can connect your customers through the network. So hardware means that the cloud will provide you with the servers, and also the cloud will provide you with the storage. So with that, what we mean is that cloud will provide you with the servers that you can use to install your softwares and your operating system and other necessary components, and also give you enough storage to do all your operations. So the storage means the SSD memory storage spaces that will be sufficient for you to do all the work. And then we will have the virtualization part. So in there, we will be given virtualization softwares to manage our resources efficiently. So when we have virtualization, we are able to manage the storage space and the hardware such that we can control the hardware in such a way that we do the operations in the most optimal manner based on the demands. So for example, if we have a virtualization technique, then we can use that technique to divide the resources we have to multiple chunks and use those different chunks to do different tasks. So what I mean by that is that initially we had a server with about 12 GB or number of GB memory, then you can decide whether like you're going to use the 12 GB entirely for the certain task that you want to do with the cloud server, or else do you want to use this storage and for different tasks which will be done in different virtual machines. So we can create different virtual machines to do different tasks. So we can allocate 4 GB for each virtual machine, and we can give different tasks for each virtual machine to do. So if one virtual machine does some one task, a separate task which is entirely different can be given to the second virtual machine. So likewise, we can give different functions to different virtual machines, and by doing that, the simultaneously we can do all these tasks at once. So otherwise, if we have only this 12 GB and then we want to carry out one task, then we have to allocate, we have to use all these 12 GB for that certain task at the same at a certain time instance. So with that, we will be actually doing one task. However, sometimes we might not be able to run multiple different tasks at the same time. So therefore, with the virtualization, we are able to do multiple tasks at the same time, which will actually enable us to do different tasks simultaneously. Sometimes this could be more optimized, such that the customers are given the services on time. The resources allocated for each function is, however, reduced when we consider with this situation where we use this entire space to provide one service to a certain customer, for example. So if we, for example, consider a scenario where we provide like a service to a customer, a certain customer, without virtualization, then sometimes you will only be able to provide services for a customer during a certain time instance. However, when we have these three virtual machines set up, we can provide services to different customers at the same time. So with that possibility, we can actually increase our efficiency in providing our services to different number of customers who are accessing our infrastructure for a certain service. So I think with this virtualization function, there's a lot of benefit for the customer who's accessing the network. So therefore, the infrastructure also, its service quality also will increase because of that. So with that, actually, the infrastructure as a service has like a large portion of control over the infrastructure. However, like when we go into the platform as a service have control over mainly the software building part of the cloud infrastructure. So what we mean by software building part is that in here we have three actually sections. So in here, application and data will basically relate to building softwares. So we this will we will be known as a software layer. So this application and data will be related to building a certain software. When you're building a certain software, you require data input. And then also you need the application. It's it's specific components of the application. So with the application and the data, you can do the application layer work. And then so when we discuss about the platform as a service, you will be actually given the control over the software layer to build the necessary softwares for your company. So when you consider with the infrastructure as a service, in the infrastructure as a service, you are basically given the control over the like the you are given control over the over these three components like operating system, middleware, and also you will be given control over the runtime. So you will be controlling over the runtime as well. So those are the all the things that will be controlled by you if you are using the infrastructure as a service. So basically, when we have platform as a service, application and data is something that you will be controlling. So application and data you will be controlling. Other things will be controlled by the cloud service provider. So the entire rest of the things that are related to the operating system and the middleware, those things will be controlled by the cloud. These things will be controlled by the cloud. So same as infrastructure as service, these components will be controlled by the cloud or the platform as a service as well. So when we talk about the software as a service, the software as a service or SAAS is actually a service where the user do not have to do any kind of development, but the user will just need to use the software. So there's nothing that is under the control of the user. The controlling part is not there, but the using or the using part where the user can use the service is available. So all the components are controlled by the the cloud, the cloud will control all the components that we have discussed, like application, data, operating system, and middleware, and all the other components like related to networking, hardware, storage. Storage and virtualization. Those will be all controlled by the cloud in this instance. The user will not be controlling any of the components in the cloud. The user will basically be using the service without any control. So the user is therefore just a person who's accessing the service. They don't have any control over the cloud infrastructure. So there are many examples for each of these uh, service types. So if you take the infrastructure as a service, is like provided as services by companies such as, for example, Amazon Web Services. Amazon Web Services will provide it as a service. So I will write those things in a different place. So infrastructure as a service is some service that is provided by companies such as Google, Amazon, then Microsoft, then IBM. So likewise, there are many companies which are like providing IAAS as a service model as a service. So they will be providing the infrastructure to the customer. The customer has to build the infrastructure on their own. So this is good for like startups which want to build their own infrastructure on their own, or else like big companies like Amazon also maintains their own infrastructure uh, and controls all the components in that according to their own preference. So for such kind of companies, this infrastructure as a service would be good. So infrastructure as a service. So the next one is the platform as a service, which we call as PAAS. So platform as a service is a software, software development service where you are given the ability to build software. So the examples would be some platforms, right? The platforms will be provided as services. So this platform is given to the users to build their own softwares. So some of those examples are Google App Engine, then Heroku, and so on. So there are some app development platforms which are given for you to develop your apps. Then if you consider the software as a service or SaaS, SaaS is a service that provides the customer with all the software and hardware requirements, and the customer do not need to install anything in their computer. All the requirements related to hardware, software, they are all provided by the service provider. So the examples will constitute of examples related to like Google Drive, and related, services such as Google Docs, Google Sheets, Google presentation slides, and so on. Then we can consider the Dropbox as another software as a service. And another service is the Gmail. Gmail also you can use without installing Gmail software in your own computer. While if you just have access to internet, you can access the Gmail, you can have your own account, and you can have this service. So you don't need to have anything installed in your computer. So that is the advantage or the difference of SaaS with the other two service models. So if you take all these three like service models, if you are considering the perspective of a developer, for example, the flexibility of developing the infrastructure or controlling the infrastructure increases as we go up in this manner, like from SAAS to IAAS. The flexibility of like flexibility of controlling the infrastructure increases. The flexibility of controlling increases. So you can build your own customized service related to cloud services using these service models. However, if you go down in here, the user ease of use for the user increases. So ease of use increases. So you actually just use whatever the service that is provided by the vendor. So the ease of use increases once you go down in this order from IAAS to SAAS. So ease of use increases once you go down from IAAS to SAAS. So that is something that we can see. So when we consider about the different aspects of these service models, with the IAAS, you can create your own infrastructure and customize your own softwares in the way you want. And then you can also customize the software stacks. Such kind of works can be done. However, one thing to note is that you need some experts to manage the infrastructure. So the kind of a difficulty with the infrastructure as a service would be that you have to manage your own infrastructure. Then you have to have experts to manage the system, experts to manage the infrastructure. You need experts to manage the infrastructure. So persons with good knowledge about network architecture are needed to manage this kind of infrastructure. When we consider about the platform as a service, it allows the users to develop softwares and deploy the softwares and um, uh, you know like uh, build them uh, and sell them to customers. They can provide the service through the cloud infrastructure, and they can customize the software as they want. This is a good point. So they can customize the softwares as they want, as they prefer. Okay. With the SAAS, one thing you can notice is that you can use all these services without any hardware software installed in your computer. However, using these services comes with a risk of security of your data, right? So the security of your data at the vendors. So security is at a risk uh, at the vendors. So security risk is there. Any questions up to this point? Okay, now going back to the overall scenario, we have discussed about cloud computing in detail by now. So now we have to discuss about the fog computing and the edge computing. So why do we need to actually use this kind of computing? Is a question that we have to raise. So why do we need this edge computing, fog computing applications? So, what is the reason for all these computing methods? Do you know about that? Can you suggest a reason? there's no reason, right? So with the amount of data that is entering this our network, especially at an IoT network, which is having many sensors and many devices connected to the network, the amount of data that we are uploading to the network increases. So in that scenario, if you have a situation where you cannot, send large bulks of data through to the cloud server and then get it back with, because you need to do the processing within milliseconds of delay. So if you have such a kind of application scenarios, then you need to have an computing server at the nearest location to the access point at the local network. So we will discuss about the need for the edge computing and the fog computing, and then we will like then we can understand like what are the applications of the edge computing and fog computing. So if you consider a scenario where the like a certain set of sensors are connected to an access point, the you consider IoT application, then we will be having a set of sensors which we are placing in a certain, maybe a certain field where we are measuring something uh, at those locations. So if we measure temperature data, let's say we are measuring temperature at all these locations in the area, in the local area, we are collecting that information at a certain, access point. That access point we will consider as the router in here. So each of the sensors will be connected to maybe Wi-Fi to this router. Each sensor will send their data to this access point. So it could be wireless link or wired link. I don't think it's going to be wired link. Most of the time it's going to be wireless link. So if that is the case, I think I will draw it like in that manner. So they are not connected to directly to this access point, but they are connected through maybe wireless links. The reason being that the sensors are placed in very remote locations compared to the access point. So if they are connected through these links, so if there's a large bulk of data accessing the router or the access point at a certain time instance, then that large bulk of data need to be uploaded to the internet and and then to the cloud server where the processing can be done. So if the router is connected to other routers and other network components in this manner, we can consider that the amount of routers and switches that are intermediate are large number of devices. There are large number of devices between the cloud server and the edge server or the edge point. So in here, this if we have the cloud server, and if you have this set of routers, switches, and other components in between, the amount of time that it takes for this data to reach from this edge point, right, the edge to the cloud can be of a certain range, which is considerably high for that application. So if we consider that it takes 5 minutes to upload the data to the cloud server, 5 minutes, that 5-minute delay is sometimes going to cause some problems with the quality of the quality of the products at the IoT network. So let's say you're you're maintaining like a fish fish market or fish selling vending machine, for example. Then if you lose the temperature and then if your temperature increases below a certain threshold, this fish will not be in a good quality. In order for you to control the temperature sensors, you need the data in a very low latency manner. So if it is another food, like some kind of food which you need to keep within certain temperature level, then you need that to do that very quickly, and within milliseconds of latency. So we cannot wait for 5 minutes. So in that case, we have to take the decision at the nearest location possible. And that is why we do the computation in a very closest position possible to the devices or the IoT devices. So these IoT, devices will be, connected to that server, which is doing all the computation, and then the data will be processed there. The decisions will be taken by that edge server and will be communicated back to the sensors or the devices in the network. With this approach, the amount of time or delay that takes to give back the feedback will reduce immensely. We can consider that the delay will be in the range of about 1 millisecond or in the range of milliseconds if you use this approach. So with that, we can increase the efficiency of the communication for application scenarios where we need a real-time feedback regarding the environmental conditions. So edge computing is useful for such kind of applications where you need real-time feedback from the processors about the environment conditions. And then we need some data regarding the locations of the devices. And also we want to increase the data we provide to the users as well. So based on all that, we can actually have edge computing technology at the edge of the network to provide faster services. So edge router is placed at the location where this local area network ends. Right, so local area network is the local network that is defined for the IoT application scenario, right? So for certain application, if you are connecting all these devices into one network, into one local network, that local network we consider as the network which is connected to a certain one access point. So with that network, you will have a certain point where you have a boundary which connects to the other, like offset network or the outside network. So this outside network is connected to the local network at a certain location. So this is the outside network which constitutes of the internet, for example. And this outside network is connected to this local network at a certain point. And that point is known as the edge of the network. The edge of the network is the point where this local network connects with the outer network. So the edge is something that is defining the boundary of the local network, the place where the local network ends and the place where the external network starts. So that point where this new network starts is known as the edge. So at the edge, you have the access point, and then you have the server which is connected to the access point, and the server will be doing all the processing. So I will draw the server. So server will be connected to the access point, and then the server will receive all this data that is coming from the access point. The server will be connected to the edge access point, and that server will do all the edge computing tasks. So this server is also somewhere very near to this access point. So this server will do all the work related to the processing of the data, and this server is known as the edge server. Edge server will give any kind of important decisions back to the access point, where the access point will communicate that to the necessary users. So edge computing is a demanding technology for application where the where the the application scenario requires high processing, high processing, uh, high processing, and then high, data management power, and then energy management power, and then also the data security can be provided at this edge server, and so on and so on. For different applications, we can for different user requirements, we can provide those services to the customers. So the edge server will be able to provide security for the data. Then also it will manage the data management and analysis will be done. So basically data processing will be done at the edge server. Then also it can use concepts related to machine learning, for example. So edge AI is something that we will be discussing later. So edge AI also can be applied at the server. So edge server can do intelligent decisions, or it can make some intelligent decisions based on the data that it receives over time and predict what's going to happen in the next time instance in this local area network. So based on the what's going to happen in the next time instance, it's going to make some decisions on how to optimize, for example, the network bandwidth, for example, right? Network bandwidth, and then also decide which components should be actively used in the network and which can be not used. And then we can have, active and sleep nodes. So we can manage the as I said before, we can manage the network bandwidth, we can manage the network energy efficiency, and also we can manage the reliability of the communication using the edge server support. So in the real world, we are using edge computing in scenarios, mainly in situations where we have like manufacturing situations where we are going to control a device at the edge of the network. So in manufacturing sites, we have, robot management, and then we have to control the robot. So such kind of robot dynamic, controlling can be done using the edge computer. So robot arm control can be done using the edge servers. So only the necessary work can be done through the robot arm controlling. So if there's any kind of hazardous scenario, we can control the robot arm using our edge computing. So also we can also have a situation where we are controlling the product line. So we can control the product line, and we can stop the product line if we observe there's a fault in the products, and so on. So such kind of things are there with the edge computing. Also, we can, as I said, we have many applications of edge server. We can use edge server for image processing activities also. So images can be processed and different detections can be done at the edge server. So the predictions of, like different, faults in the products or any kind of environmental environmental change, you can, see and, predict using this image processing. So that kind of, so those are some of the applications that the edge server is able to provide. So another thing is that edge server is actually a very resourceful server in the entire network, in the entire local network. So when we consider edge server is a very powerful computer that is able to provide, many resources. So when we consider about the edge servers and its capabilities, edge server is able to do like processing, like large data processing activities. It also like has really good connectivity with the network. So data processing is like something that the edge server is doing with with efficiency. So then network connectivity also is provided. Network connectivity also is provided to the different devices using the edge server, and it's making the decisions for the network connectivity. So the edge server is able to connect to the access point and also manage the network connections in the local network. If the server observes some network losses, then it will also try to uh, correct the faults and then uh, come up with the network connectivity again. So with all those things, the edge server is able to provide data processing, network connectivity to the local area network devices, then storage of data, storage space. It will provide for the local area network data, uploading. So storage that is sufficient for the data will be there in the edge server. So, depending on the scale of the IoT network, the space that is allocated in the edge server will be defined. Then memory allocations will be also there. So there will be sufficient memory also available at the edge server for the application. So that is basically regarding the edge computing. Then there's something related to the edge computing, which is known as multi-access edge computing. So multi-access edge computing is another kind of a very similar version of edge computing. So it is actually related to mobile telecommunication systems. So this multi-access edge computing services, multi-access edge computing. Multi-access edge computing is a service which is done basically with the assistance of the mobile telecommunication services. So the edge computing that we can do with the assistance of mobile telecommunication services, we call as multi-access edge computing. So edge computing that is done with the assistance of mobile telecom services, we call as multi-access edge computing. So in there, the main difference with the normal edge computing is that we are integrating the mobile telecommunication infrastructure into this edge computing scenario. Whereas, like if we have a base station, the base station will be connected, or there will be a storage space where you connect the edge server. So you will connect the edge server into the processing unit of the base station. And then in the edge server, all the necessary data processing will be done. So the edge server, which is connected to the network infrastructure, will be able to send the data to maybe the core network very fast with low latency. So in the earlier case, we had this router and then we had this connection with the other routers and switches in the network, and then we go to the cloud server. So sometimes, like with the connection with the network infrastructure directly, the network service providers which are providing the telecommunication services will support in this data communication to the necessary destination. So it would be an added service that will be added to the network to transmit the data efficiently through the devices. So in cases where we have other users accessing the network, this kind of approach with the multi-access edge computing will enable any kind of users to access the network without any delay. So for example, if there's some kind of a IoT network, then the IoT network will also be accessing the network infrastructure. Apart from that, there will be other users who are using the network infrastructure for other, mobile call applications. So in all those use cases, the network infrastructure is able to give the resources for the communication without any problem, mainly because it has a inbuilt infrastructure already for the application. So infrastructure that is provided by the network telecommunication systems is kind of stable because it has been, providing services for a very, large time for a lot of users. So there are millions of, or I mean, thousands of users who are accessing the network infrastructure at a certain time instance, and the network service providers are already capable of providing services for like massive number of users. So if that is like occurring, it's not going to be a problem for them to provide services to multiple sensors and massive number of sensors and or devices that are there in a certain IoT network. So the network infrastructure will be connected like this. So first the base station will be there that will be accessing, that will be obtaining all the data from the IoT sensors, and then all other devices will also take calls, and they will also initiate communication with the access point, and then the access point will then forward the necessary data to the edge server. The edge server can make decisions and give a feedback. So the and then the GNB or the base station will give feedback back to the necessary IoT devices regarding the edge server's output, regarding the environment and other any data that is required for the IoT devices. Then the data will also be able to quickly access the internet through the core network, and then it will access the internet. Then it will access the cloud server, and the cloud server will give a feedback regarding the IoT environment, and that also can be quickly surpassed back to the IoT network through the network infrastructure which is already built. So the network infrastructure which is used can be sufficient for the uh, the uh, the communication to happen without any latency. The in the general edge computing scenarios, sometimes when we are using Wi-Fi or a Bluetooth or LoRa, for example, our communication link might not be that stable with the access point. So as I said before, like cellular communication technology is a good method to communicate once we want high data rates and also high communication range. So cellular communication infrastructure or a cellular communication technology is what is dominating the multi-access edge computing method. When we are considering about the normal edge computing method, in the normal edge computing method, we can use Wi-Fi, Bluetooth, LoRa, and so on, depending on the strength of the communication link in that situation with that certain technology. The communication link might not be that stable in the multi-access edge computing. However, since we are using the cellular architecture, most of the time, whenever we use the cellular architecture, we can directly communicate with the base station or the GNB without any problem, because these technologies have been built many times, and therefore it has the capability of giving connectivity to any device within the coverage range. So most of the time, base stations have a coverage range of about 1 kilometer, 1.5 kilometers. So up to that point, you can send the data to the network infrastructure directly. And also the network infrastructure is available in many places, and therefore the users can easily access such network infrastructure. So that's regarding the multi-access systems. And the latency in these kind of multi-access systems also can be achieved to a value which is below 10 milliseconds, or we can take it to a millisecond range using this system. And also we can consider mobility scenarios. We can consider mobility aspects of the devices, and we can serve the devices requirements without any issue, even under mobility scenarios. So the network infrastructure which related to telecommunications network infrastructure is able to handle customers who are moving. So moving customers can be dealt with using this multi-access edge computing. So mobility can be addressed, and there's no problem with that. Low latency, we can consider clear to you. Any questions up to this point? Okay, so if you don't have any questions, I will share the attendance.